Good afternoon. I come from a discipline which is, if you're discussing the point that students, both undergraduate and graduate level, even postgraduate level, are drifting away from science. Earth science, from discipline of science that I come from, there are hardly any students coming. We are at the lowest rung of preference, even among sciences. So if you have 100 students, 80 of them are going to professional courses, or 50 of them are going to professional courses, 30 are going to maybe economics, MBA, things, management. I think 2 or 1 is trickling down to earth science. So we have a serious problem here. But I would like to say that earth science is a very complex subject in the very simple sense that Earth is a very complex planet in many ways. Earth science, there's nothing like earth science. It's just a combination of different basic and applied sciences, the knowledge of which you apply to the problem solving in Earth-related issues. And people look up to earth science only when there are crises. So if you have an earthquake, you see a lot of seismologists talking on the television or newspapers and things like that. And if you have a water scarcity, then I've got colleagues here like SNRI and all, they go to those areas and do a lot of geophysical surveys and other surveys and try to bring in some solution to the problem then. So somehow, for some reason, earth science has taken, although it's very, very lucrative, I would say earth scientists, if you go to oil industry, if you go to other industries where geophysicists or geologists are paid pretty heavily, even as consultants. A lot of the Geological Survey of India officers, they are going to Africa, South Africa, Latin America, and they're making huge careers after their retirement, after the superannuation in Geological Survey of India. That's what. So earth science is a little less recognized, but a very, very lucrative career. But I think there is a very little awareness among the school children, other even undergraduate children is very less. That's partly because of the way earth science was being taught. Earth science, actually some of the concepts in earth science are being taught under geography in the school textbooks. And yesterday we heard Professor Balasubramanian talking about a textbook that they wrote without these barriers, no physics, no biology, no chemistry, but they wrote what you see, materials around us. Had things been taught in that sense, materials around us, then earth science would have been automatically very popular, because we are dealing with materials around us in a very different way. So, very, very exciting things about earth science, and India was doing very well with earth science. And we had, like 150 years back, we had a Geological Survey of India, which was one of the oldest geological surveys. Until technology was limited to what is called a microscope or simple devices like that, earth scientists in India did extremely well. They were the best petrographers, they understood the rocks, things like that. But then when the requirement of technology became much, much more as time progressed, earth science in India was starting to take a back seat. Now if you have to analyze a rock, you have to you have to analyze every rock, for example. Most of the rocks would have like hundreds of elements in them. They're like aggregates of all kinds of compounds. There could be silicates, phosphates, carbonates, so all kinds of organic, also inorganic materials in a very complex crystal structure. So you need very sophisticated instrumentation to analyze these rocks. If you want to analyze waters, if you want to talk about arsenic pollution in Ganga waters, you require very specific analytical methods. Similarly, anything that you do in earth science now has become technology intensive. So it's that. So teaching earth science in the schools, introducing concepts in physics, chemistry, biology, mathematics, which you would apply to Earth, or any object for that matter, whether it's a man-made matter or natural material. I think the school's science should take care of teaching the basic concepts how to use these concepts to materials which are very general. So the science education should be very generic at the school, and then people will take, from there on, people will take on into specializations as they would get. Everybody will not have the same interest. Some people will get attracted to something or the other. So people will get different interests. So there is this kind of a science education policy that we need a little tinkering on that kind of the way we teach the science. And I really personally I liked the concept that Professor Bhargava and Professor Balasubramanian talked about their 6th class or 7th class textbook with no compartments of science, implicit or explicitly in the chapters. So that's one thing. The second thing is that how do we attract people into earth science? One of the things that we're trying to do in earth science is actually create natural museums. And this concept is just taking place, and I think we already have some, but they are not maintained very well. So if I go to any place around Hyderabad, you see some of the spectacular rock outcrops that you have, a huge boulder sitting delicately balanced on another rock. And how does that happen? So it takes millions of years for a landscape to evolve. And how does this happen? And that kind of things, before they're destroyed by human building, road constructions or buildings and all that, there are something like at least 150 or 200 instances where the whole world can come to India and watch what natural, what we call them natural museums can be created on those things. So I think the scientists themselves have to create such museums, both outdoor and indoors, and to attract students into interest in earth science. And also, all these experiments that you talk about, like he talked about magnetism, just a little while ago, Professor Mohan talked about magnetism. How we apply how Earth behaves as a huge magnet, and how we apply magnetism to explore certain magnetic properties, and how we map those magnetically magnetite or hematite enriched rocks, and how we exploit the magnetism, electrical resistivity, electrical conductivity, or there are a whole lot of more complex multi-parametric methods. So all these can be demonstrated actually. We can actually, so the problem is that you have to have certain technology to demonstrate these things, but then the concepts have to be introduced very early. And I think even there's a good future for our science if these small things can be taken care of at the school level. I think this will go unending, but if you have questions, then I think it would be better to respond to specific questions at that stage. So I end here, and I think I'll pass it back to our chairman.
Thank you very much.